Record. Hey, welcome to Coffee Compiler Club. Starting a little bit late because I had too much fun hacking. Here today to talk about compilers and language runtimes and any and every other thing on the planet that has to do with what computers do, maybe. Um, I don't typically have any set agenda. We're all being recorded. We'll show up on YouTube in a couple hours. That's my spiel. We have one new person here. River, are you interested in giving a 10-second summary of why you're here?
Sure. Hello. I'm here because uh, have been absorbing. I've been learning from the YouTube recordings of this group, sort of just by osmosis, listening to what you guys have been talking about. I don't know. I'm interested in compilers, broadly speaking. I don't have any particular area of expertise or interest. Yeah, just here to learn.
Cool.
Nice, nice. Welcome.
Yeah. So I have a minor set agenda. I don't have any set agenda. I have a minor thing. I want to whine about the state of fucking default libraries for doing simple text processing. And in the course of my life here, let me go find my share button. I'm gonna throw this thing up here. Um, no. Oh, hang on. So Zoom wants to grab my expand your font button. Let go Zoom. And so it won't feed the keystrokes to Emacs. So then I can't scale Emacs. Okay, here we go. So like through the course of my life, here, actually, let's do this maybe first. I have had reasons to parse log files on and off all the time. It happens every year, sometimes many times a year. A few startups, I had to do bajillions of log files. But most jobs, somebody comes along and says, "Oh, I puked all this junk out into a file, and we're trying to sort something, and the data's in there somewhere. Go find it." Um, so here's a sample log file from the 80s and 90s, text format from a fintech trading. I've anonymized and cleaned it up a little bit. Um, Prior startup, I was eating this stuff by the terabyte, not even gigabyte, by the terabytes, and didn't do machine learning and stuff on it, right? Looking for fraud in the stock market. But many other times I have done IoT devices with vast log dumps and just people doing things in their data center where they puked vast logs and then like, oh, go process this and figure something out. So, okay, it's text processing. How hard can it be? Well, okay, so I wrote this thing in Java and discovered that all your time was spent in running out of memory bandwidth because the default libraries would just allocate a string for everything you're parsed. So I whipped up a C++ version. Here's the C++ version round one. And, I'll step you through very quickly here. I'm going to pick my file. I put it on the command line. I have two files easily available. One's 3.5 gigs. So it's bigger than all your CPU caches. You're into memory bandwidth realms. Open the file, look for the header line, break out some headers because they vary by the file and the format, whatever. Make sure your headers are all present. Then go do something here. Here's the old version. Let me go show you the old version. And this version was very similar to the one I did in Java. We centered a little bit. Process file two. Okay, I'm going to go open this thing up.
Your font is
And
very small, by the way. Can
I'm
you
sorry, what is very small?
small font size?
It's too small.
Yep,
How about
that's
now?
better.
Okay. Yeah, and then I've read the header, so I'm going to seek past the header, and then I'm going to read 10 million lines or 1 million, okay, many millions of lines. I'm going to call, oh, this is process file two. Where's process file one? Here's process file one. Of course, the font's huge, so I can't find myself. So I worked for a while on this version of things to try and make life easier or faster or something. And this is like run an iterator over the function, getting a line at a time, pull a column out based on index source, and there's a filter that says throw away some count of columns. Clean up some other string objects, get a bunch of other columns out, and then look them up in a hash table. If you don't find, make one. Okay, so there are about 1,000 products. These are fintech being traded on the Chicago Mercantile Exchange. So soybean futures and corn and Henry Huggins oil and that kind of stuff. Um, If you don't find one, go make one and then collect some crap. And of course, for the real problem, I would collect a little more stuff and do a lot more math here. But all the times in your memory bandwidth and the cost to go gather things is like irrelevant. To go do math is irrelevant. It's just completely like mind-numbingly easy. So this version of things under GCC-02-03-fast-machine native is about 4 times slower than my good Java version. 4 times slower. Well, the good Java version came from a bad Java version, which was a similar one, where I just said, for all lines, get me a line, pull some strings out, do the math. That one was also about 4 times slower than the fast Java version. And both of these are just using standard libraries to parse a file line by line, go grab the next line, and then pull strings out. And like that's the default easy way to go plow through, except it's not even easy here. I tried really hard to reuse string objects. I'm not making new strings every loop through. If I got rid of this stuff where I make these clears and just put strings as the default behavior, just say get column gives me a string out, right? And get column just walks looking, counting commas, finds a comma separated column, and then pulls it out as a string. And then I do a little string math on the things, like I have to use it as a key in a hash table. I have to do, are you a buy or a sell? I have to turn you to an int to do some number math. Okay. Where's all the time go? Why is this version 4 times slower than Java, than the fast Java version? That to be fair, fast Java version. It's because all your time goes in making strings. Every string you make somehow is runs you out of memory bandwidth. Now in Java, I get it. A bump pointer allocation says I bump, I bump, I bump, I bump, I bump. Well, I'm bumping 10 million lines and I'm bumping for every 10 million times 70 columns. And that bump continuously gets me a new address, which is never in my caches since the last GC cycle. Hard guaranteed, never in your caches since the last GC cycle. Hard cache miss, all your bandwidth is gone. You're out of bandwidth, that's where your time goes. Don't allocate in a hot loop. You'll blow out your memory bandwidth. Okay, I would claim, I would think in C++ that I would get these things back and they would get freed and then they would just come back around from malloc again. If they don't, I don't know what the hell's going on. Or I didn't run out of memory, but I certainly ran out of memory bandwidth. So I went and finally did the version in C that I'm doing, or C++ I'm doing in Java, and oh, I got the speed right back. So I have another version, that's process file 2, which does things the dumb, hard, like things that you could totally do in a library. Like they really ought to be available in the library. Like, I get it that I want a next line function somewhere in the library that just gives me a string, is a little convenient, but I want a version that doesn't copy also, because 4 and 5x slowdowns are worth having a separate API in a library that's not like slow. Okay, what's the fast version do? This is very, very similar to what the Java version's doing. Here's my private next line, same thing, while not end of file, get column 2 instead of get columns, producing a string view. What's a string view? Well, it's a pair of pointers to the base and offset of a string in the buffer. And of course, there's a buffer back here. And I have to preload the buffer with a fill command. And then next line guarantees that the next entire line is in my buffer, which means I can't handle lines bigger than my buffer size, but my buffer is much, much larger than my lines. So that's not a problem. And then instead of allocating by copying the string bits into a string object, and then copying the string objects column by column into another string object, and then saying, oh, hash you and turn you to a number and da 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 da. He says, I give you a pointer into this buffer, and then take this and use him to hash and look in the hash table, or take him and convert him to a number, or whatever you're going to do with him. That's 4x speed up. Why isn't there an API baked in already? So I wrote next line and I wrote get column 2. What do these things look like here? Well, get column 2 looks just pretty much what you expect. There's a mem card, a hunt for a comma. Count your columns, count, comma, 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 got the right column. Again, one more, find the end of the column, string view it. Okay, that seems pretty stupid. Why is that not available somewhere? Here's next line. Next line's a little more complicated. He says, I want to know that I have already found an end of this line previously, but let's say it didn't, just starting in. Go hunt for a new line and get my position somewhere. I've found the end of well, I found the start of the line, I found the end of the line. Now I'll go make sure the rest of the line fits in the buffer. If it doesn't, I have to go do a fill down here. And if it does, I'm going to record the end of the line. So what I'm really doing here is I'm saying, usually 99% of the time, I have a line somewhere in the middle. That's at pause. I have an end of line. I know the end of line. I want to skip it. So I'm just going to bump pause to the end of line. Okay, now I have a line start for the next line here. Did this fit my buffer? Look at my monitor screen. It goes right off the edge of the screen. Oh, it didn't fit. Well, I'm going to have to copy this. That's what Phil does. I'm going to copy this down to the start and then load in the rest of the buffer here. Buffer there. Right. Okay. Or it did fit. And then I have a new line here, and then I'm going to go column, 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 column to the end. So this kind of a hand over hand, check for end of line, fill, move if you need to, fill, blah, blah, blah. It's a little nitpicky. It's never any rocket science. It's just a little fiddly this, a little fiddly that. Perfect shit for a library. Why don't I have this in a library where I can say next line and have him, and here's Phil, which just says, hey, if I have to copy a slide half line to the start, I do. Otherwise, when, fill the rest of the buffer up. Why did I have to write this code? Why is it in either library? These are 25-year-old libraries, and missing this code is a 4x slowdown. It's one page of code. What the hell? Okay, so that's my whine. I am done whining. Fuck.
To be fair, I'm not surprised that IOStream is slow. It predates the STL. If you recall, STL was the library that introduced the containers, iterators, and algorithms to the C++
Yeah.
standard library, and it was adopted in 1998. IOStream design predates that. IOStream was already done in the early 90s.
But
And
this
C++
is
did get a replacement eventually for the output part. It's called format now. So format, you are not really supposed to use IOStream anymore. It is getting proposals for the input part now, and I posted two libraries, one of the is proposed. So
okay,
the
because
output got better. The output got better.
all
One of
right,
the
all right,
libraries it claims it doesn't do heap allocations if you use the
right.
API, static API, so that's out there.
All right, so the default standard lib is what I started with. It was 5x slower. I went to this strings where I recopied and cleaned the strings up, not recopied. I re-cleared and reused the strings and was only 4x slower. And this was what I thought was standard lib. This is all out of standard libraries, right? You're saying don't use iStream iterator and iStream, but use something else now. There's a newer version. All right. Did I get that right? Let me kill this. Go find chat.
For the output part, for the output part, you do have format, but for the input, that's still in the proposal stage. So now you would have to use a third-party library. To be fair, that's gotten easier too. You don't have package managers, and I checked these are all both on the package on the package managers. So
So scnlib is like somebody,
Scanlib or INI.io. Yeah, I would try these two.
huh? I would,
I have a
okay.
naive question.
They're also much
Um,
faster than the standard.
so your string representation is pointer to start of the string view representation is pointer to start and pointer to end, I think. Does that mean that you're issuing the entire 3.5 gig read upfront into
No,
one
no, 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 no.
contiguous?
In real life, the file must be streamed. And to make it fast, it's generally streamed in parallel with different people grabbing different chunks. So this is all a streaming operation.
Got
So
it.
under the hood, I started with the default buffer size, and then once I got other things cleared up, increasing the default buffer size gave me some performance. So I increased it from 8K to 64K and saw, a gradually diminishing returns where it rapidly sped up from 8 to 16, and then you tailed off. The difference between the 32K and the 64K buffer was just barely above noise. But yeah, but those were second order effects. First order effect was you allocated, you lost. Do not allocate. And oh, it's C++. All allocations are hidden in copy constructors everywhere, and it's hard to say that you did have a copy or you didn't. Where it happened. So there was like nightmare. Go find where the performance goes. Well, it goes in your copies. Where's your copy? Oh, geez. The Java version is not a whole lot better. Hey, buffer.getLine, just like the next line I was doing right there. Yes, it's a copy. Doesn't say so. String split. Yes, it's a copy. Doesn't say so. Pardon.
Why is it that in real life it must be streamed?
Oh, because the files are always larger than any machine's memory.
I see. Gotcha.
I say streamed, but for a reasonably modestly large machine, you can get a terabyte of RAM. It's a terabyte-ish. They didn't go much beyond a terabyte. There would be many terabytes of them, but there wouldn't be any individual file much larger. So you could get it, but then you wanted to be parallel anyhow. So you didn't necessarily expect to do a read of the whole thing in one shot. You wanted to go to different offsets. And then, at different times in my life, I did seek in parallel, like 16 core machine would each core would seek to a different offset, or you min map the whole thing. And then each guy reaches out to a different offset in the min map section. And you could get away with min mapping. This is a reasonable thing to do.
Hmm.
In both Java and C++, it's one of the ways to go there. But the default lib of I have a file, I know it's big. You can you can ask the file length when open. Hey, look, it's a terabyte. Okay, it's big. And now I'm going to read it all. Okay. And look for things. Don't make strings for every look for things because every time you made a string, you ran out of bandwidth and that was straight to your bottom line.
And don't hide the copies from me in the constructors.
And then in the
That's
language
so
design, don't
frustrating.
hide the copies from me so that when I recognize that I have a problem with copies, I can now go hunt them down and figure out what I'm going to do about them. And the actual memory management here is very trivial. Any individual processing element, a line, fits easily in some local buffer you make that you hang on to forever. And so at most, you should copy into the buffer without allocating a new buffer so you don't get fresh virtual addresses that burn out your cache. But in fact, you actually still don't want to copy from the network buffer, the file buffer, the OS buffer. You just want to look in the OS buffer and look for things in the OS buffer as you go. And that's what a string view does. And for Java, I had to actually make a version of string view, semantically identical. Does the same kind of thing, base and offset, and does a number conversion, and it does an equality check, and it does a hash code, and does whatever things you have to do. But it's known to be backed by the network buffer. And when the network buffer shuffles, which it must shuffle, then the string pointer goes dead on you, and you have to go make a private copy if you need to hang on to it. In this case, the products that were in the files are typically 1,000-ish out of 10 million rows. Each row is a K, so you have 10 gigs or something, and 1,000 products you have to hang on to for the hash table. But that would be one part in 100,000 or something that you actually copy the string. All right, done. That was my whine of today. I was trying to figure out why GCC was polishing up my GCC skills, C++ skills, and lo and behold, it was just as slow as Java versions, the bad ones. And I was like, no, no, no. It's supposed to be fast. It wasn't. Okay, what else? Not much on simple. I've been massively job interviewing all week. It's going okay. Middle of trying to get separate compilation going for simple, which along the way says I have to make decisions, a high level compiler design decision upon discovering a unknown symbol. Kind of like a couple different choices of what to do. One is you've had an import statement. The import brought in the symbol. Your design is if you see imports at the top, you deal with them first. Now the symbol's not unknown. So if you find an unknown symbol, it's actually a bug, and it's a programmer bug, and you report unknown symbol, go away. In the land of Java, those imports go to class files. The class files have to exist in pre-cooked format, and they can load the type data in. If they don't exist in a pre-cooked format, then they recursively go compile them. Now they have a pre-cooked format, and you get a new class file that has the pre-cooked type data, and you suck it in. So that leads to decision number two. Upon discovering a symbol and go hunt for it in the file system, in my case, looking for .o's instead of Java's .classes, but look for the symbol in some class path. object file path. And if you find it, you're going to suck it in, and that'll be your definition. And if you don't find it, you have to recursively go build it. Now your parser has to be called recursively. In the middle of parsing one thing, I'm going to go parse another thing. Do I want to go do that or not? And then my other option is upon finding an unknown symbol, I'm going to put on the list of things to go resolve in a minute, this unknown symbol. And then I can parse with an unknown symbol and roll forward just like the normal parse, except that I can't get the type of the unknown symbol to the end of the parse. So the parser can never depend on knowing the type of the symbol, which means that your parse syntax can't use semantic knowledge to parse. So I have a symbol foo, and then later you say foo.bar. Is bar a field in foo? Um, I don't know what foo is. Foo's a function. This is illegal code or something, right? It's just like, or maybe foo is a struct and it's got a bar field. Maybe it's a static field and it's supposed to be a global. Maybe it's a instance field and I have to do a load. And maybe it's something else and I don't know what. And okay. So those are what I'm sorting out right now. What am I doing with separate compilation? And I'm trying hard not to have import statements, which means I'm into the other two realms. I'm either going to get recursive on you, or I'm going to say I'm going to live. At the moment, I'm trying to live with no knowledge of semantic knowledge of what an unknown symbol is. And at the end of the parse, I will then, in a loop and not recursively, go start another parse of the files in question to go get the definition for foo. Somewhere in the world, I'll find a foo.o, and if I fail, that search will also tell me where to find foo.c or foo.simple. And if that fails, then you have an unknown symbol.
Why are you hesitant to make parsing recursive? Isn't that sort of the core idea of recursive descent parsing, for
Yeah, right.
example?
It's a recursive descent parser because there's a lot of static fields right now to make life a lot easier for other things. And I'd have to go turn them all into non-statics and then pass them through whatever 1,000 places. It's not the end of the world, and I could totally do that. It does put a limit on how deep you can go before you blow your stack out. So in the realm of small things, which is all things simple right now, but if I go to, some big Java guy and he's going to load 50,000 classes, I have seen such, things, and he starts compiling them, yeah, he'll be in the middle and say, yeah, let me go again. Oh, in the middle of this guy. Oh, go again, go again, go again, go again, go again, go again. How many times? Yeah, 20, 30, 40, 50 deep. You blow your stack out. So then you get into an explicit stack, which is what effectively I do by delaying things to the end. I get a work list. And so this parse finishes with incomplete knowledge somehow. And now I pull something off the work list and go again.
What happens at a module boundary?
This is the module boundary. This is exactly the module boundary. You've said foo.bar without announcing foo anywhere. Okay, foo came from a separate module. That's what that means. Or separate compilation. Well, that's okay. No, wait. We say module. Let's just break up. What are the things? So my current theory is there is a tree. There's a root of the tree. There are directories. Everything in here is within one namespace, and I'll find foo in there. If I want to, oh, okay, yeah. So if I want to have a module boundary, then on the command line, I have to include the module that includes the name for foo. So it looks like a class path for Java. So you say, go read this jar file as part of the things, and I'll go hunt for foo in the jar file. But I'm not going to go compile that other module. You're going to hand it to me.
Why is ClassPath better than sort of dynamically discovering it the way Python does?
That's what I'm trying. Well, so I'm trying to do the discovery with I have them all ahead of time. I'm trying to do discovery in the Java-like way because you can get the entire module system description. You have it up front, or you can find it up front. You don't have to execute any code to go find the module description. So you pushed on me for this for AA, and I went back and forth, and it looked really cool. And I'm back on the other side of the equation. No runtime execution to find your missing symbols. There is a val, there's class for name. That's a different beast. But if you're not one of those guys, then theory says it suffices to grovel through the files to come up with the set of all possible symbols you have to have without running any code.
What about a list of unresolved symbols, the way we talked about a few CCC backs? A list of symbols that will bubble up, of unresolved symbols,
Yeah,
and will bubble up, and eventually it will discover them in the .o files.
that's what I'm headed for. So I have an unknown symbol foo, and foo says dot bar. I'm going to assume that foo must be a struct with a bar field, but then it's not defined here, so it bubbles up. Yeah, and then it hits the
Mhm.
top, and I say, oh, I have an unresolved foo.
It will you will simple won't the parser won't go looking for it. It will continue parsing. Or
Yeah, no. At the time that foo.bar happens, he has to keep carry on. He's nested, recursive descent,
yeah,
nested way deep in the parse.
yeah.
So he found a foo, he doesn't know what to do with it, so he calls out a forward ref and carries on. Now he finds a dot bar on a forward ref. Well, he upgrades the type of the forward ref to being an unknown struct which has a bar field and it may have other fields. It's an unknown struct. Okay. And then he carries on from there, but he has foo in the current scope. That scope ends, foo's not defined. It bubbles up a scope when the scope ends. This happens until it bubbles all the way to the top. At the end of the parse of a file, he has a list of a list of forward references that never got defined. At that time, he says, okay, now I'm going to do the file system hunt, which would be like the import statements for Java or pound include for C++. I'm going to do a file system hunt for foo.
At the end, when it reaches all of the unresolved definitions reach the root of the parse, the root of the
Yeah,
directory.
yeah,
And and that's the time, well, we didn't find it in all of the source codes. It's
yeah,
code. It's time to look for all the Dodo files in order
yeah.
to resolve the unbound symbols right now.
Right. We have one. We have a one file we just finished parsing. It wasn't in this file. So
Mhm.
now what do we do? And then the next question is, do I look on the command lines class path first before I hunt in the local, like I look for modules that you listed
Mhm.
before I look in the current
How
and
about
go override on
other
a module the current
how
definitions in the
how
directory tree.
about other simple files? So
Yeah, or other symbols, or it's the
file.
other way around. I'm
So
going
the
to
first,
search.
yeah,
Okay, so somewhere when you launched the compilation of simple, you gave me the
mhm,
root of your project,
yeah,
and I'm going to hunt the root of the project for uh, uh, the foo in the and I have to hunt the whole thing actually. The foo path will be fully qualified. It
mhm,
must be, or that is a different. That's a different kind of error. So it's fully
yeah,
qualified because you didn't put any shortcuts on the name. Uh,
mhm,
then I'll just start from the root and watch the qualifications till I get to a foo file. If that didn't work, then I'll go to the module set and see if there's an equivalent path through each of the module routes that you've listed when you did the compile.
yeah.
And I think the only difference there is a hunt locally or a module, which is a pre-cooked, somebody else's local compilation that's been pre-cooked for me to go
Yeah,
hunt.
because we are looking potentially a lot of delays in the parsing because it's not just the foo dot bar, all the symbols that are equal foo dot bar or the symbol had been referenced by this unresolved definition. It will it will have to be rescheduled on the list once they find its
Yeah, right.
definition.
So the you only get so far. You have very weak type info like foo.bar, but what did bar load? Wow, I don't know. Loaded some other unknown value. So you don't get a lot of progress in the people optimizer parser section of things as soon as you start hitting unresolved symbols.
Mhm. So
Um,
basically, that all of the, at least I've seen most of the techniques I've seen, they follow the same path. They're not in the work list. For example, Scala, it's like a completer. It's the same thing. It's a delayed resolution of the definition,
yeah.
and that triggers all the completers of all unresolved definitions for it depends on, and it's basically it rediscovers the way it has to be parsed in order to find all the definitions one by one.
And
Oh,
how do
It
you make sure you
this
don't end up
the
with cyclic
yeah
dependencies in
you
this
have to you,
context?
you
oh, okay. So separate things here. So As far as I know, the IR I'll come out of the parsher will be valid, but I'll upgrade the forward reference to point to the real thing, which will promptly then trigger the work list to go clean out the next set of things. And then cyclic dependencies, you take your pick on resolution mechanisms.
Mm.
That their common ones are, I hate you, you have an error, die. Look for the cycle and then proclaim error and fail out. Um, Other things I've been looking at are can I take a module's definitions as each separable piece so I don't say cyclic dependencies from module to module to module or from file to file to file. I'll say this module has a foo. Foo doesn't depend on other things in the module, so I can just proclaim foo is okay. I have a definition for it, and life goes on. I otherwise currently support Do I support cyclic? I didn't do the big one. No, I don't put cyclic types yet in simple. So that's not true. I was going to say I started down the path of cyclic types in simple. I don't have the I don't have the minimal resolution things like AA does. So if you have a truly cyclic type, I should no, no, no. Oh, and I don't need it in simple. The reason I don't need it in simple is because you have to put a name. And I'll just treat the name as the head, and that you can have the name of a type point to some other types and point back to the name, and that's fine. So I don't need it yet.
So simple can't have linked list node that has a pointer to optional linked list node?
No, he can. But you have to say it's linked list node. AA does this entirely with anonymous, and two anonymous structs that look alike aren't in fact equal. But there's no one of them that you would point and say you're a linked list. And because it's linked list, and I have a hash table that takes a linked list string and maps to a type, I don't have that in AA. I have to do cyclic type, not just resolution. I have to do equivalency on cyclic types. Whereas in AA, I'm going to say I have these two things. Are they equal or not? That question comes up 1,000 times over. And the first thing it says is, well, what's the head of you? You have a head. You have a head. Oh, it's called linked list. Okay, you have a head. Okay, is it called linked list? You're equal or not based on that. Done. And that I can't do that in AA, so I need a much more fancier algorithm. But in simple, I just said, no, I'm not going to handle that kind of anonymous class definition. So you have a name, therefore you have a head of your cycle. Therefore, I can confirm equivalency by saying you two names are the same. And then if I actually want to do fancier things, like I have a linked list of optionals of linked lists, then I go to the next step starting from a known good point where they have to be equal. Are these pieces equal? And then recursively are these? And if they hit here, yes. And if they don't hit here, then no. Or whatever, right? You handle the cycle sort of straightforwardly at that point. The AA version requires DFA minimization algorithm because you're basically taking two large graphs of types. And are these equivalent? And the general graph equivalency test is NP complete, but these are all labeled edges. The structs all have a field names. Because your edges are all labeled, it's not the general problem, but it still requires DFA minimization. Whereas the one in simple is just going to be a recursive descent equality check. And then because it's recursive descent, I can share individual pieces down the line, and then it becomes an instant test. These two are equal if their immediate children are equal, and if their immediate children are unequal, they're unequal, and you're just done. So it's a fast, cheap test for the simple because the typing system's weaker. Fine. All right. Something else was me whining about libraries and then types. And the types are going, whatever. The simple upgrade is moving along, but not super fast.
What was the status of Java getting things without headers and dense arrays? Wasn't there a project Valhalla for like 15
Yeah,
years of
yeah, it's still going on. It's usable. As my understanding is it's usable, but it hasn't become the default. I know it says Valhalla. We go ask the interwebs. And that one, the problem they have is they're trying to be 100% backwards compatible and also do the actual thing. But the 100% backwards compatible issue is you have to support effectively. It looks like you
Yeah,
have a
objects have to opt in to not having identity.
right. There's something going on. Okay, so um it's still in according to Wikipedia. It's probably not the right place to in the JEP. It's 10, 15, no, not 15, 10, 11 years long. It's still going on. You can get without identity. You have issues with null and nullables because you can't ask nullable you don't have a pointer to an object because it's an identityless wad in a giant array.
Yes, if you
And
instantiate an object that has a non-nullable field, it can't be null by the time the constructor's done
yeah.
running.
Um, and the equals operator does it based on the contents instead of the pointer, but it lives.
And it doesn't have a
Um,
pointer, it has no identity. So
right, yeah, right. Um, and they have all kinds of rules about when they give up and go slow, and they're probably trying to figure out. Let me see if I can find the. Oh, I don't want to go to OpenJDK project page.
because
Ah,
I
here
think
we
that's
go.
one of the lessons designing a language now is
Yeah.
having non-null and having non-identity
Uh,
seem useful.
well, okay, so clearly it hasn't happened yet, or I'm on an old guy. Oh, geez, this is a 2021. Where is some modern? Yeah, I don't have it. I don't. Somebody find me a better link. This is a Matt thing. Where's a better link, Matt? Um, that's exactly where I was at. 2024, big news. I don't want the newscast, thanks. So the answer is as of 2024, October, so late 2024, it was not yet the mainstream, but they're still working on it. Which, yeah, so I think the answer is it's coming. It's not here yet.
It has an
Not
early
time to
access.
rewrite the billion row challenge in Java with Valhalla and see if it mattered.
Right. Now the billion rule challenge won't because everyone stepped around those issues because of lack of valhalla. All the winning scores all dodged. Exactly. Sorry, Theodore, you were going to say something?
No, I just saw a link that it has a early build. Maybe it's
It's had
included
an
in
early
some.
release for a long time. Yeah, you can
Oh,
always download the version. That's a good point, though. If I were to write a billion row challenge using Valhalla, would it look any better? And, the answer is probably no. I'm sorry. Here's this is another text file parse, right? Just like I was just doing, giant text file parse, and you're going to pair the winning score is going to parallelize. You're going to min map, so you have ugly for min map. You're going to parallelize, which you have to have edge cases on parallelized, hunting into these giant pile of things, right? So that already makes you pretty damn ugly. Okay, now that you're in, so some ranged pieces, you've got some evil edge cases you've taken care of, and you have however many gigabytes this one core is going to go do out of the thing. Um, what is where does the Valhalla help you? Okay, well, you're not converting it to a data format and hanging on to it. You're one time sweeping through. You find cities lazily, so you throw into a hash table the cities that you find, and then you accumulate min, max, sum, squared, whatever of the temperatures, right? It's very similar to what I was doing. Um, if I was to do this with H2O, which totally did the Valhalla thing, but manually by me and H2O people to go do, the vertical compression without headers. Um, if you were to hang on to the data and to make repeated passes because you're doing some sort of machine learning algorithm on it, some sort of AI, neural network, blah, 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 whatever. Yes, you totally want to do a thing where you compress the crap out of it and use the Valhalla like approach. which like that was what H2O exactly did. Or you got 10,000 cities. Okay, here's an enum of 10,000. That's 16 bits. Okay, that's your cities. Now you have three-digit integer temperatures. Well, they all turn into 256 choices, scaled, biased, byte temperatures. Okay, now I have a billion 16-bit things and a billion byte things. 24 bytes times a billion is not that bad. And then you make pass over, pass over, pass over it, and it's all good.
Yeah, to me, the value in something like Valhalla is less you fundamentally can write Java code that is faster than a thing that could be done before, but getting away from there's a pattern I've seen a few times where you have a big block comment at the top that is the slow Java code that straightforwardly
Yeah,
does the thing that
right,
you're doing.
right.
And then under it is the mem map pointer fiddly
Yes,
thing that is
yes,
actually
yes.
fixed.
For I equals 1 to bajillion rows, get line, get column,
If
string
I am
init.
tempted to document my algorithm
Yeah,
in Java code for my Java code,
right. That's what I'm doing. Yeah,
that is where Valhalla, I think, would shine, is maybe running the code at the top should do the thing at the bottom.
right. So make sure the code top actually still works. It
It's about
well,
breaking the trade-off between nice, clean, readable algorithm
right.
and high performant
Yeah,
code.
yeah,
If your nice, clean, readable algorithm can be the high performant code, that's a real win.
yeah. But if you had two versions, what you're proposing, there is an easy to read slow version. Right. And if you go look at my C++ code, I have this fairly easy to read. If I got rid of the string clears and resets, then I have a fairly easy to read thing that would just say iterator, for iterator, next line, and get columns 1, well, 4, 7, 9, 11, 12, 13, 15, whatever, and then blow the rest off. If filter, exit, else, probe hash table, blah, 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 10 lines of business logic. And then it's pretty obvious what it's doing. Okay, that one's only 5x slower, 4x slower. It's not happy. And then the fast version has an extra, page and a half, 2 pages of code that says do the thing that you don't want to do. Fine. Yes, and then Valhalla version. Yeah, yeah, sure.
I mean, you get rid of that test that's like run the slow version, run the fast version on this 10 megabyte small randomly generated
Yeah.
example and see if they get the same answer.
Yes, yes.
Like
And then it's
that's an
testable.
annoying test, but you need that test because you
Yep,
can think about the slow code better than you can
yep.
think about the fast code.
No, no, I've
But
done that.
Valhalla can make a lot of that go away by just giving up identity on your string and say, okay, I've got this string that doesn't have identity, so now it doesn't have a pointer, so now the system can not make those copies.
Yeah, I don't know if they do that for strings. I thought they were doing it for various kinds of primitives. You're claiming that Valhalla includes no header strings. It might.
Right.
That's
You
a
essentially make a identityless class that is a compact struct.
no, but right. So what's the
So I
reference?
want my array of a billion complex numbers.
No, the billion complex numbers I get because they're fixed size. So the finding the value says base plus scaled offset done. In the billion strings, it's all irregular sized. So I don't even know where the string borders are unless I parse and look for my commas.
Yeah, the Valhalla thing to do there would be to say, I'm parsing a billion strings that I promise you will never be more than a K or something like that.
Yeah, right. Right. That was the thing that I was complaining about was I know that my row is less than some modest number. The buffer is much larger. You'll always fit, and I'm done with it before the buffer rolls. And I make you this promise, I'm done with the string for the buffer rolls. Can't you do something
Yeah.
better in the standard lib?
And if you try and assemble a fixed length string that's longer, then you're just going to throw an exception
I'm gonna
and
throw an exception. Yeah.
handle the exception because those don't
Yeah.
happen that often.
Yeah. Yes. And in the case of the data sets I'm looking at for the fintech folks, the lines were 100 to 1,000 characters long, hardly ever more than 1,000, and then not much. But the files were, a billion of them at 1,000 a pop, so terabyte in size. Yeah, fine. You go to the billion row challenge, the rows were under 50 characters, 30 or something like that. That is one or two of the cities were 20-ish characters, and you had like 6 or 8 other characters. So you were getting close to 30 characters. They're really tiny. It was an
I don't
interesting
remember what it was.
variation.
I was reviewing something once that had strings less than 64 characters, strings less than 512 characters, and
Ah,
then the rest of the strings in three different arrays.
right. Yeah. Yeah. If you could go, if you're planning on revisiting the data repeatedly, then it pays a lot to get a better format, however that looks like.
But in
All
Java,
right.
it's non-trivial to ask for data to be laid out in a way.
No, no, it's not. No, no, no. So like I do this writing simple IR, CF nodes IR out to the .o files and reading back in. So I have a bijection, knock on plastic. It hasn't stayed a bit rotted on me. But now you have to write something out that you can read in. And the guy who does the writing doesn't necessarily have all the information up front that he wants to write for the reader who wants to read it first before he reads the rest of it. And then I have these different kinds of things I'm writing out. So there's some strings to be written out. And then I want to reuse all the strings elsewhere. And I don't want to write them out again. So there's a string table and an index. At least types to write out. And the types all have these indices into each other that have to be under a type space. And then there's IR, there's a bunch of nodes, and they have a node space. So there's a bunch of different namespaces for hard indices that are just numbers because you're going to a disk file. You're not a pointer anymore. Right, so the pointer thing's really nice, which is why we use them. But you go to a disk, you don't have any pointers. So instead, you get a million different kinds of indices, and then you unwind from an index to a pointer, and you have something equivalent already where you're unwinding into, and it has its own pointer, and then you have to say, I loaded a type from the file. I have the same type over here. I actually want to, unify them. So at some point, I have to go through the types I've generated from the file and look at the types I've been carrying around all along and say, okay, all you types are all the same types or not. And so there's a lot of sort of messy stuff going on there. The
Yeah,
nodes
that's
are
one of
easier
those
to,
trust the compiler games where it's like,
um,
I have this function that there's three specialized versions of because the fields got put in different orders. But if I could guarantee that all of the structs put the fields with this is field one, this is field
yeah,
two, and this is
right.
field three, then I wouldn't need specialized versions of the functions.
Oh, I see. It is
And you just sort of trust the compiler is going to notice that and lay out the objects, right?
only if somebody wrote the code to do that. That's certainly the case that if I'm in parsing this file over here and I see foo bar and foo baz and foo quux in some order, I say I have, well, foo is a struct that has at least bar, baz, and quux, and I put them in the order I discovered them. And then this file over here says, oh, I have a foo. I don't know what it is either. I've got fields, quux, baz, ABC, and they overlap and they're not in the same order and whatever. And when I start unifying them, I want to say foo has bar, bax, quaz, and ABC. And here's the definition, and they're in different order yet again. And so I can't just, sort of hash on them. I got to say, okay, wait, do a
Yeah.
sort and
So the place where I learned that was with a C code base, where someone decided to put in this linter rule thing that alphabetized all of the fields and all of the structs.
Isn't
yes.
that sort of a dangerous idea in C because of alignment issues?
No.
Yeah, so when we alphabetized all the structs, the thing went to about 6% of the speed it had before we alphabetized the
Oh,
structs.
really? Okay.
And it turns out in Java, alphabetizing your structs seems to have no
No
noticeable
effect.
performance impact. And
And
in C, alphabetizing your structs can have dramatic performance impact because suddenly anything that's got a field that would have broken your header, it's like, no, no, this object is very much these five fields are the header and these five fields are the class specific behavior.
right.
And most of the functions only operate on the header. But if you suddenly put one thing in there and the header gets shifted down, you need two copies of a whole bunch of things and you're getting iCache blowout because you're loading and
That's weird. Because
it
just
was
language
like, can you
Java.
please not touch the C code from the 60s? Somebody thought really hard about this.
Right, right,
Just
right, right. So,
exempt it from all the rules.
so Java definitely looks at your list of header of fields and sorts them according to placement and alignment and whatever tightness, packs them in, right? He doesn't do anything with padding for false sharing, but that's a really more of a niche case. I want to say I certainly worked on C compilers that would shuffle objects that weren't being extended. But if you had a header and then you said also add fields and also add fields, he got scared and didn't do anything. And I'm wondering now if that's the C rules, C++ rule. Oh, you know what? Yeah, you just said it. They just extended the header.
Yeah, I think this got better in C++ than it was
C++,
in C.
you have a class that said these and then these, and this extends, but these are a private thing I can shuffle. But C guys who fake having C++ object are saying I have a perfectly shared layout. You're right. You're right. You can't do it in C.
Right, in C++,
Yeah, as far
you
as
just
I
put all the
know,
things that are shared
the
in the superclass and all the things that are not shared in the
Right.
subclass, and it
Right.
does the right thing.
Right. Sorry. Were you saying something, River?
I was just saying, as far as I know, C compilers are not allowed to do
Yeah.
reordering.
Yeah. Yeah, which is kind of a waste and a shame, but fine. Yeah, but it's from history. It's what it is. So
I
you
mean, you kind of can't if you want to have stable ABI, then you cannot really reorder it. I think it would have to be something that the user has to opt in, that
right,
this struct doesn't have to be passed or stable across the ABI boundaries.
right.
Internal use only, maybe static, for example, if it's a static to a translation unit,
Yeah,
then feel
ditting
free
for the
to.
win. You get a new layout every time you run a new JVM at the sum of all classes you've loaded because he does the layout whatever he wants to do each time. And if you generate machine code, as you're saying there, generate machine code, you're also generating data layouts and you're stuck at the data layout. Could you mark all the field offsets in the generated code and then allow for a dynamically generated data layout that was done at startup of some kind? Somebody looks at the metadata structures of everything involved. The final link step where you link everyone together, you stop and you look and then say, okay, all these things have been compiled except for some offsets buried in all the loads and stores and whatever. And then I now have the list of everything. So I'm going to do data layout for my structs. And then I'm going to
I
pass.
think C sharp has packed an annotation or something that dictates the
Right.
I
Wait, is
think
the
C
question
sharp.
that the normal object file formats can handle that kind of information, or just like if could
Yeah,
you do this
whatever. Yeah,
in theory?
whatever. What could fail or not fail here? The local object formats, I believe, could handle that in the sense that they just you carry any extra data along that you want to carry along.
Mhm.
What or do field offsets get wedged into other weird calculations that you're never gonna want? I mean, I know you can. Um, so size of, right? Suppose that I'm laying your object header out the C way where I can't change anything, and then I get a size of. That's a known constant value that somebody wants to propagate through, and he does some math and he hides it from me. Then at load link time or final link step, global optimizer link time, he says, "Oh, okay. So I have this guy with some sub and some subs, but this guy, he's a whole unit. No one looks in the middle of him, so I could repack him and no one could tell. So I'm going to shuffle things to get alignment and fill in the padding holes and stuff. Now he shrinks by 20%, so I get 20% more of my Dcache, so I run 20% faster, maybe. Yeah. And then I've changed all the field offsets, or I pre-announced that to do this, you can't have nailed your field offsets to a known value and folded them. They had to be just a field offset somehow buried in the thing. And then I went through all the relocations, find all the field offsets, and they say things like, it's field X. And then also there was a +2 or a -5 or whatever other relative references you're adding into the base. I don't care what. But I found all the field X's and I changed their constants from magic field X to 5 or whatever my offset happens to be. And then size of course, changes and went from being 64 bytes to 48 bytes. And somebody said, I constant folded 64 times the million entry table array. No, it's only 48 million entry arrays and whatever. I don't know. It's like, what are the possible fail modes here?
So if you decide to keep around a little extra metadata and say, not only do I have these field offsets, but these are the names of those field
Yes,
offsets, can I
gotcha.
make the distinction between ABI and API totally go away because I can just look at the names and say, oh, I need to shuffle this one?
That's a good point.
Because if I can make the ABI be the API by just adding the names of fields in structs
Right,
to the .o file,
right.
that feels like a lot of value for very little ballooning of the size
So
of the .os.
I've been heading that way in simple. As part of the separate compilation, I went from I don't know, I have field offsets to I don't know how to do the layout until I get every other thing. So all field offsets in the IR are now named. And then there's a point where I say, I am done. I know everything I need to know. I'm now going to do field layouts. And then I change all the names to numbers. And then I go back to the peoples and you constant fold them all.
Right.
But
And
I need to lay
even if
that
someone
decision.
does a dynamic link at runtime,
Yeah,
you just need to have the machinery around to do that rewriting for your dynamic link as part of whatever your class for name.
right.
And as you mentioned earlier, there's even still the idea of generating the accessors at runtime. There is this interesting work someone is doing the unboxed data for dependent types. I posted this earlier. And if you think about it, unboxed data for dependent types is really challenging because depending on the runtime value, you can return either an integer or a pair of integers from the same function because the type now can depend on the term runtime value. So now you have to make sure that if you return this integer or you return two integers, you're going to have still contiguity. And the functions that access this return type know how to work this type. So
But I think
basically, what they are doing is generating also the runtime code for index computation.
Is
And then
this
depending on that, is going to compute different indexes, values.
is this the Marmoset papers you've put out?
That's the types 2025. I think unboxed data with dependent types. It's a presentation.
I
the
see.
fourth link, the fourth link.
Yeah, yeah, I don't want to run a video during
But
the.
more generally, since it's
There are
can it
also
be
slides.
Yeah, let me hit the slides here.
completely can it be completely different type? Because what I heard that it's a subtype of integer, some kind, but it turns maybe it can be a completely different type. So that would be bad.
Yeah,
Yeah,
it,
but so
in general, it
he's
could be a
basically adding layouts
completely
to these
different.
type
Hmm.
arrangements of data in memory. But yeah,
Oh.
that's exactly the slide that Cliff is showing.
Yeah.
Mhm.
That's the basic challenge. Because you don't know the size in bytes at compile time. So you're gonna have to likely generate some runtime index computation. You can still lay it out contiguously. That's the interesting part. That's the achievement. But you still have to
Oh,
compute some location in memory.
yeah, see, I want the stack allocated unboxed data as the default. And you have to be explicit when you want to box and
I know the OCaml people are also working on this kind of
who?
control.
Yeah, it's Richard Eisenberg. He's the same
Oh,
person who was working on the implementation on box data types in Haskell. So the
yeah.
solution that the OXCaml is ended up is very similar to GHC's unboxed types.
Okay, fine. Interesting. Interesting. I'm kind of like only I'm not going that far down the path. I'm just going to say not dependent types for sure, but it might say size of is a dynamic unknown value. It's not a constant until final link stage, and then I'll fold it right after that. But then you do some amount of cogen, although you could imagine doing cogen where size of remains an unknown value that you're going to fill in, um, which means you might have to do some runtime math on the size of because the binary wants it to have a value in the binary that I'm just going to patch a
That's
number
kind
on.
of already we are doing some kind of multi-staged programming on multi-staged compilation. When linking it can be a stage, but also runtime startup can be a stage. So I
Yeah.
think it's a smooth progression to something like dependent typing at some point, especially if you want to have efficiently compiled dependent typing. It's like use stage compilation.
I'm trying very hard not to do anything with dependent types. I've done a lot of interesting type things in my life, and I don't like dependent types, so I'm just not going to go deal.
The user ergonomics are still not great for that, yeah, I have to admit.
Probably wise if you want to actually finish the compiler.
Exactly, exactly. Yes.
Or if you want
And,
the
You have
compiler to
arrays
finish
of
compiling.
integers. Isn't that a dependent
no,
type?
let me
Because
finish.
array is dependent on integer.
Uh,
I was gonna have Matt, you were saying something.
Oh, I just was joking that if you wanted the compiler to finish compiling too.
Finish the compiler, finish compiling. Yes.
Yeah.
I, I was merely in the place if I want the compiler to generate code that looks like something I'd want to see executed to run reasonably well. Fine.
to answer Aaron's question, I think the idea of dependent types is that you have types that depend on values that inhabit another type, not names of other types. So it would
Yeah.
have to be like an array of length 5 in particular, because 5 is a value.
But if the size of the array is runtime, that kind of that's something you would like to express in a type sometimes, especially if for matrices in vector, like if you have a matrix multiplication and you want conformable matrix, it's really convenient to have that.
So this is the at runtime, if B is Boolean is true or false, then yeah.
Either you're returning integer 1 or you're returning a pair of integers 1 comma 1. So that's
Yeah.
also an example of that. But most languages would pretty much do what one would call type erasure, when even though you know at some point in the compiler you have an array of size 5 or array of size s, you erase this s. You don't compile it into the
Yeah, so
hierarchy.
how does type erasure relate to the problem that this paper that you mentioned is solving? Th Those sound like very similar problems to me. As far as I understand, the problem of type erasure is like, hey, now we have types that can depend on values, and so to represent our values, we have to like keep track of type information at runtime.
Sure. Yes.
But lots of times that's actually not going to get used for actual runtime decisions, and we want to try to figure out, can we throw away as much of that data as possible? That sounds very, very similar to me to,
So Java
um,
generics, the
yeah.
generics get thrown away. You have the base, so you have a list of foods. Well, the of foo gets thrown away, right? There's a list.
Mhm.
But the list internally is carrying, it happens to only be carrying foo objects, but dynamically you can't tell that an array of foos or a list of foos actually only has foos in it because there's no guarantees out of the typing system that's actually true, right? So you can cheat, is what it amounts to. And then that means that the runtime rechecks when you load out of a generic array of foos, array of generic foos, whatever, array of generic array of foods. When you load out, he says, "Is this a foo?" He does an instance of check. Um, if you have an array of foos in the Java system, that's a separate thing, and he can make the type system, lets the compiler get rid of checks. But if you have a generics of whatever kind of thing, I have a hash table of strings to persons, then inside that the hash table, when he gives a get and he returns you a person, that's been erased. The runtime does not know that it's a person. The compiler has to put a instance of check on person on you, and then you can cheat that um, by writing bad bytecodes that pass the verifier, but they don't pass the generics, but you can write them. So the compiler, I mean, the runtime has to check. Like the format on disk that you would pull up and do verification with does not have enough stuff to internally say this, you must check. So you get a billion
And
runtime checks.
and it will fail with the class cast exception if it turns out
Yeah,
there
and
isn't.
then you'll fail at class cast. So it's safe, it's runtime safe, but it's dynamically safety checked. It's like Python that you get a runtime error.
Mhm.
But you only get them if you've played the cheaty game at the class file format level. Like if you just take Java C at its word and just use Java C, he will check those generics. But if
Mhm.
you go in and hack a class file, you can make a legal class file, and then the pass the verifiers, the compiler can't tell, the JIT can't tell that you did or did not pass Java C, so he has to check in.
At least, and when when I understand the deal with dependent types, they are only cool if the data they are dependent on are known at compile time. So it can be statically discharged. If it cannot find the type, it resorts to a runtime check. So you have to
Right.
feel it like a match on the thing, and if it's this, then do that. So then if it's this type, then do this. And if it cannot discharge, if it cannot eliminate that, then it will
Right.
fall back to a runtime, to a
Yes
runtime
Think it
check.
would.
and no, because you can also have symbolic reasoning. So you may not need to know that the runtime value of the array size or matrix list size is 5 by 4, and then you are trying to multiply by matrix that is 4 by 3. It's enough to know that it is A by B and B by C. And as long as you have a proof of equality of B equals B, like by reflexivity, you do not need to compile a check for that. So if a proof is available in the context at compile time, if equality proof is available statically,
Yeah,
even for symbolic values, then you are fine.
I just said if you cannot, if it can find
But you
statically.
don't, right, you don't need to know the values. You don't need to know that B is equal to 5 at runtime. You only need to know
Oh,
B is equal to B, so to speak.
okay, okay,
So
okay.
it's
So
it's
when
symbolic equality is okay. You don't need to have runtime equality if that makes
so
sense.
when you're making the code, instead of having 5 for 5, you don't know what the 5 is. You could say B is B, and then you can skip the
Right,
check.
because maybe it came from another function that also obtained B from the same source.
Right. Right.
From then you know
Mhm.
this of compile time, even though without you have no clue what the actual value is, you don't
So,
need to know
in the
that.
land of some most normal optimizing compilers, if I put a check in that was the output of this array versus input of that array, and I also had later said this array length came from here and that array length came from here, common sub-expression would have been the same. And then he would say, I have a runtime check, or I have a check I put in the IR that said if B equals B, oh, if that's dead, I mean, I'll just throw it away. So that one just falls out of, kind of normal optimizing compiler things. If the bounds are turned into things that a compiler can track.
I
So
think you
not just
also fall into that with a lot of reading untrusted files from disk. You can have a SQLite schema that you're reading, and in the middle of your table of integers, one of them's a string.
yes.
Okay, well, you're gonna get a runtime exception for that. Parquet can have things that are the wrong file types.
Yeah, yeah.
You must.
I looked at taking H2O's data format to disk, and in that case, I'd put metadata on the header, and then if you had a malformed disk file, I would reject you, just like you have a broken gzip. I want to unzip this gzip, and it's a, whatever, it's a gzip bomb. Somebody's trying to hack you.
I pickled this object, I changed the byte that tells you what the type is, I
Yeah.
unpickled the object, and it's like, you can't put a
Yeah.
signed
Mhm.
integer into this unsigned integer field.
That some
Yeah.
unpickling
No.
would say, this data file's broken. So something got changed, doesn't count no more. I'm not going to do anything with it. Go away.
I mean, I have been shocked at the degree to which people don't just say this data file is broken, I'm done. They say, I'm gonna put a null here and just keep going and
Oh, just to
hope
keep
that the
going.
brokenness doesn't matter.
In the land of giant CSV files for startups reading giant CSV files, you ate every possible CSV you could and did every kind of rescue attempt on reading it you could. But in the end, you only ever produced out 2D column or table with with some reasonable things in every column.
Then you get this exciting thing when you have every different JSON parser is attempting a heroic rescue, but it attempts this heroic rescue in a different way. So
Ah,
there is
right.
no such thing as JSON because there is no standardized handling of JSON parsing.
Right. Right. CSV is really loosey-goosey, but kind of sort of your intuition still lines up with what it means to rescue a broken CSV.
Oh yeah. And then
Whereas in
there's
JSON, I can
then
see, yeah,
even for CSV, there's this lovely thing that Microsoft does in Excel when it depends on the localization settings of your system. Like if you're using the European language like German,
yeah,
it's CSV does not stand for comma separated values now, it stands for semicolon separated values because some European languages use commas for the decimal separator.
The H2O CSV parser, you can tell it what it's supposed to be, but it has this heroic guess. And it definitely checks all of those things. And it also checks all kinds of fakey other things that you would never dream of that show up. So God, I can't remember now. It was just like Excel spreadsheet layouts have nulls for column separator or something stupid. They have some weird character for column separator that's not normal, and separate and another one for column in. There's 20 or 40 obvious, well understood formats you handle immediately, and all the European ones. And then you do crap like, well, we keep finding this weird 17 character, and they're separated about the right distance, and there's no other weird column. So we're going to say, let's guess this. And shockingly, it works
Yeah, every
almost
single
all the
row
time.
has the exact same number of this byte.
Things happen, and you get them. And certainly, people will take million rows of empty columns and dump them all out. And you'll have 27 empty columns, a million rows long, and now go, what's your heuristic gonna do?
Yeah, my data science class at Georgia Tech had a bunch of things where he just gathered real data files that he could get
Yeah.
from the world and asked people to parse them.
Yes, that's a good one. Yes.
And one of them had this column that everything in the column was an integer between 0 and 100,
Yes.
except for one of them where someone had written out the number 9 in English.
Oh, in English. Oh, so a famous example is the Titanic survivors data set, which has like 1,500 people in the Titanic and has their name and their passenger ID and their cabin number and blah, 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 and their age. And the ages are numbered from 1 to 100, except for this one baby who was 2 months old. And so it was 2 divided by 12, 0.1666, or whatever it's going to be, right?
In in one of the parsers, I have written like a sampler. It samples the data if it's too big, and it tells you basically can it be one type. If it has a variation, it will tell you it's either this or 0.001% is this, and you can acknowledge it. But if it's all convertible, then it will say you can fit in one type, which was handy for basically
Yeah.
this.
My favorite one from this professor's interesting CSVs was the dump of all of the star ratings for all of the movies on IMDb,
Ah, yes, okay.
which there's 10 stars, so everything is either 0, point 0.1, point 0.2, point 0.3, up to
Yep.
1 for
Mhm.
except for one movie.
Oh,
So my thing is processing along, it's almost finished, it gets us to the S's, and then it just dies.
yes. And what is
And it
the
turns out
movie?
there's one movie that is not scored in tenths.
And it scored in.
Spinal Tap goes to 11.
Okay, all right.
So it's the only one that has a star rating that is not point 0.1, point 0.2, point 0.3.
Have you seen Spinal Tap? You okay, so you get the joke. Yeah, yeah, yeah. That's good. That's good.
I haven't seen it, so
Oh, the joke in the movie is it's a bunch of super 70s, 80s rock stars, and they want to turn everything up to 11. All the amps go up to 11. Like literally on the amp, it has a, up to 10. Oh, and then there's an 11 or something stupid. It's just like, oh, excess of everything. Just turn it to 11.
okay, okay. And it's the rate of the movie was 11.
And then that's the rating of the movie. Yeah, exactly. Exactly.
Fine. Cool. Okay,
Uh,
what next?
But yeah,
Next.
the real world data is terrible.
it's
Of
terrible.
Mm.
course,
Yeah.
the alternative is you can do it as the banking industry does or the airline does, which is you have one software system written in COBOL decades ago, and then you do not accept people's real names. Your
Oh,
name contains a dash. How dare you? We will display a message. Your name is invalid. But I don't think that's a great user experience either.
so
But
so
they
is your name on Discord on Zoom here? It has, I want to say Polish-ish spelling. Do you have like missing umlauts and stuff in there?
This I can live with, but
Oh,
yeah,
this you can live with. Okay.
but it comes close. Yeah.
Yeah, the Titanic data set also has double quotes around somebody's name, and then there is a non-quoted, I want to say O'Doul with an apostrophe, O apostrophe dual. So like go figure out what is a column separator. Well, it could be quotes and it could not be quotes and it could be spaces and it's not spaces in some places and is in others and whatever. It's kind of a mess to have. Yeah. extra weird characters in your name. Fine. Dots would be in people's names all the time too, in the middle. That was a known thing. Um, let's say Van Dyke, there'd be capitals in the middle. That's easy. All right, fine. Um, well, anything else? Or we're gonna make an easy early call? I'm not in a rush. I don't have anything else on. I'm closing 1,000 open windows. See if there's
So do you
something
think
over
you've
there.
spent more time on AA or simple at this point?
AA. I solved a number of very hard problems in AA that I still want to make use of in a real way. I've been gently pushing simple towards an AA, but leaving the ability to write it. The standard simple syntax looks suspiciously like C++ or Java. So I'm leaving that there, but I'm trying to get to the point where you can also just drop all the headers and stuff. That's a parsing side things. But the semantics would match fine. Um, Big things I've done with the AA typing system that I haven't brought forward in anywhere else that I don't want to abandon either is handle cyclic types with Henley Milner unification. Um, handle I believe I have an asymptotic reduction in type unification speed for a particular one of the ways that you have unification issues via fusing of the make a fresh copy of a type and then immediately unify it, fuse that to a single step, a fresh unified step. That also lets me track the cyclic types. I want to say optimistically, and that means cycles of unification types remain. I can take two different unrelated cycles, unification types, and unify them to get a cyclic type out, which if I go to this classic algorithm, it immediately throws the you can't do this. It fails the I have a self-referential check or whatever the you gotta go hunt up the name for the damn thing. There's a check they always do that says this type refers to itself. I can't. I die. Um, which means that the classic example is a function f is defined to be a function which takes itself as a first argument, and then because you exactly well, it calls itself and takes itself as its first argument. um, that gives you a
I
sick
feel like the lambda calculus people like to do that.
exactly. So I have a type for it, and the type has a cycle in it, and I'm totally good with that, and that works in all cases. And then when I do the normal parsing operations with AA, those kind of cyclic types come up all the time, just because that's the easy way to go deal with it. And then the anonymous everything is another reason they come up is because you just get a type structure with no name, but it has a complicated graph of types. I have another one. They turn out to be the equivalent. I'm asking, so I unified them, or whatever. So those there's the asymptotic speed up for fusing them. They're dealing with cyclic types. There is the overload name resolution, uh, which turns into a virtual field, not a virtual function call, but the more generic virtual field. So from a virtual field, I get a virtual function call by simply loading the virtual field and then calling, and contains a function and then call the function. That's a virtual function call. The virtual field is more generic, where I can basically tell at typing time, which of several fields in a struct you're referring to. So you don't have to name the field. So you can say, I have a struct that has a bunch of fields, and I want to just use that struct dot and then skip the field name. I'll just pick the correct field. I'll infer it. That turns it, it's like overload resolution. Pick all the fields. One of them is correct. If there's multiples, then you do throw an error. You say it's ambiguous. I can't tell. But if there's only one correct, you don't have to give the name. I'll find it.
My
That turns
plan for
into
how to actually run AA code is emit a .exe
yeah,
or
yeah, yeah. No, this all boils down to machine code that you can run as the one place you get something that you wouldn't get out of a C++ or a Java compiler JIT at runtime would be if you used a virtual field where the type of the field did depend on the flow path you took to get somewhere, and you actually need to pick the field dynamically at runtime, which would be I have a base of an object, I have an offset. I'll pass you the offset. So the hardware instruction, every hardware on the planet has this load plus register offset, not load plus fixed offset. Everyone does load plus 4 to get the field at offset 4. But now I'm going to do load at base plus another register. So reg plus reg offset. That's extremely common on all hardware. It's at most half a clock if you didn't do it because you had to
JVM
do it
keeps the
one way.
base pointer in a register basically always, right?
I'm sorry, what?
JVM tries to keep the
Yeah,
base pointers
yeah,
around.
yeah. He doesn't always, but nearly always. So in derived pointers happen in inside inner loops, and the base pointer happens to be in the stack if it's not in a register. It's around. So the GC can stop you in the middle of the hot loop and say, take all the derived addresses, subtract the base, take an offset, move everybody, re-add the base, carry on. So the base is around. But in this case, I would pass the offset, the field offset, into a function. Like I hand you the base, you call on this path, and the typing says you want field.name as the string version. And at this offset, you want field.hex, the hex value, say a color object. And sometimes I'm printing the color object for the string, and sometimes I'm using the hex value to display or whatever. So on this path in, I'm going to pass you the base of the color object and the offset to the string. And on this path in, I'll pass you the base of the color object and the offset to the int array, the int pieces of it, or whatever field I'm grabbing. That one I actually also then use to do all my function overloadings. So an overloadable function call actually gave me a tuple. So I said, you have a function called foo, and it takes an int and a string. And you have a function called foo, takes a double and a float. And you have a function called foo, and it takes an array and a blah, blah, blah. You have 5 different foos, whatever you've got. So I have an overload, which is just a tuple, standard everyday tuple, and it has 5 fields. There are 5 function pointers in those 5 fields. And then I do overload resolution by saying the same, it's just another pick the correct field. There can only be one. You have a call site here, you're pulling one of the fields out of here. Which one are you pulling out? Well, I better be able to tell it typing time, type resolution time. The overload's resolve. It's this one. Oh, okay. So along this path, I'm going to go take my base object and say field out, field number 4. That's the foo call to be made. But on this path, it's field number 3 or whatever you're going to be. So that one, I want to go code in anger using it because it should be just as fast as a normal field load, and but gives you
Yeah,
some
because all the work's
weird
at compile
flexibility.
time.
Yeah, it all boils down to compile time. Right. Now you boil away at compile time. But you get some weird new abilities to both infer unknown fields or do various kind of overload resolutions. It's a virtual field. Um, kind of like a virtual call, but done to generically on fields.
Yeah, I would be curious to see how that plays out in a way that when I was writing Rust code, we would occasionally get into these places where we had kind of painful expansions that
Yes.
you ended up passing in as an extra type parameter the value for the dynamic dispatch all over the code.
Ah, yes.
In ways that was not terrible, but just syntactically noisy.
You had to put it all over the place. That's what, so River was asking you, why do you not recursion the parse? Because I have all these statics. I don't want to pass every fucking place. It's just syntax. Everybody on the planet has to have this call. I mean, this extra argument. Yeah. Or I put it in a static loop. Fine.
But yeah, every place we were doing a hash, it was like hash colon SHA-256 that got passed. Like, just bake it into the function.
Uh,
This does not need to be dynamic. We're not going to change it probably ever.
right, right. Yes, I haven't
People
coded.
really wanted that ability to like, oh, we can just at some point change our hash function and all the rest of the logic will stay the same throughout the whole code. And it's like,
Yep. All right. Anything else? I'm going to wrap it up.
nope, sounds good.
Sounds good. Yeah, I have a
Let us
lot.
know when there's a nice compiler in AA can stick out a binary and
Exactly. Yeah, to get the fun extra field hack, which is what I'm sort of really proud of, I have to actually get Henley Milner typing going, which simple is probably never going to do. I mean, if I did, it would be I would move away from calling it a tutorial. Like now I'm into the research side of things.
Yeah, I feel like it is the right choice for simple to be straightforward flow typing.
Just right. Yep.
Um, Even just from the idea of reading simple. I find that forward flow typing, my brain can process reasonably well because I tend to read code over and down.
Yeah. Right. Yeah. Yeah.
And every once in a while in Rust, I run into this type and it's like, val this thing. And you're like, but what is that thing? And the answer is, oh, well, you scroll down and eventually there's a function that has a return type, and that return type determined what this value is because it got set to it, and then that propagates all the way up. And it's fine, and Henry Miller can totally do that, but it
Right. Right.
would
Right.
also be nice if
Right.
somewhere in the document that I'm looking at, it said what the type of this thing was. I didn't have to go look at the return type of a function that's defined somewhere else
Somewhere
to
else.
know what type this is right here.
Yeah, in AI went back and forth. I used so many times back and forth on whether returns would be part of the typing or they just had to be derivable. That I eventually got it on a flag that I could turn it on or off, and it wasn't that it changed the implementation hardly at all. It made no difference to the how the unification worked. It was just, do I want to have to deal with that way, to think about it that way or not? To know what the return is. The return verifies, changes the type involved. Like I
Yeah,
have
in the
a
same way that you've talked about potentially having a bunch of flags that are performance flags that say,
yeah,
when I'm just trying to get a thing working, be pretty lenient.
right.
But then I would like to be able to set a bunch of flags that tighten down the screws in certain areas.
Yeah, don't allocate here.
That to me feels like it should be one of a set of readability flags that says doing this inference based on the return type is totally fine and you can do that and it can compile that way. But
Yes.
when you turn on the readability flag that
Yeah.
says this will make it easier to reason about your
That,
program and now I've made this thing illegal.
yeah, that's
And it should be relatively easy for the tooling to give you the diff when you turn on that flag and say, okay,
yeah.
you need to put in types in these 7 places.
Right.
And then
Right.
I can turn in this flag that says you can't infer going backwards.
Right.
Would you like to make this diff and turn on the flag?
Yeah. Yeah. I mean,
Like,
the compiler, he inferred it, so he knows what the answer is.
right, he knows what it is. If you could totally have something that if you have it on strict mode,
Yeah.
the error that it spits out is apply this diff.
Yeah. Yeah. That sounds like more work, though. Come pile in and do error messages in general. There's a thing that's awaiting. I was doing separate compilation ahead of error messages.
Yeah.
Okay, but I need
Racket
to
has something like that when you can have basically a set of teaching languages when you enable or disable language features. And I think the interesting problem, I think they solved it actually, is that you also want the error messages to have progression. Because of course you don't want the error message to mention some underlying advanced concept if you are just using a simple subset of the language. So that's actually interesting thing. I think only Racket does something like that.
Yes. I
ah
mean, that's what I learned when I learned to use Git. Like when I was just starting to use Git in school. And I get this error message that's like, you cannot do that because your branch is currently a detached head. And I'm like, your branch is it? What the
what
heck
the
are you
fuck is a
doing?
detached head?
Just took the entire error message and went over to Google. And I get this Stack Overflow page that
Right,
says, I just got this error message from Git and I have no idea what it means. And then somebody writes 3 pages of explanation.
right, yes. I I still go to Stack Overflow for get mystery errors.
Oh,
Git
you
is a
don't know that the
great
new thing
example.
for mystery errors is to drop it into an
Cat G.
LLM?
Yeah, I'll trust Stack Overflow until it gets too polluted with LLM output. So here I am trying to go to God, somewhere local in town. Um, and I'm Googling directions on my desktop before I head out to the car and get on my phone or whatever. And it came up with the name of the thing and also the Google hits were this guy, then something in Boise, Idaho, and something that was a third thing unrelated on the East Coast. It's like three, usually I searched for go find park, blah, 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 or something, right? And I'm looking for a street in Los Gatos. It's like 30 minutes from my house and then there's one in Boise, and then there's okay. All right. Well, then there's a look at the chat AI generated answer. And the chat one was very well textually formatted, and it clearly fused those three things, the top three links together, and says, Park Fort da 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 is, can be found blah blah. It contains this, and is right next to Boise, Idaho, and it's also in North Carolina. And it's like, no, stop! What the hell?
Yeah,
I'm still
that's
not.
always annoying.
I'm
The
not.
other one of search being so good that it's less helpful. Every once in a while, I type into map something misspelled because my spelling is terrible. And it will be like, do you mean this restaurant in Africa because you've stumbled upon a word that is actually a word in an obscure language? I'm like,
Yes, yes. It's like, no, I'm not really intending to drive to Africa.
it's like, yes, your search has become less useful for me by
Yeah.
looking at a language I don't speak.
Let me get my jet ski. What was the Google thing when you went driving directions to Hawaii?
Swim across the ocean.
Yeah, well, they had one that was like go to LA, rent a jet ski. Like that, they knew that it shouldn't have done that, so they went ahead and hacked the thing in. Rent a jet ski west, 300 hours.
I don't remember what the actual bug was, but I know that they had these funny connections between things on different continents because they were trying to fix bugs where if the routes weren't possible, the queries got really expensive.
As opposed to just saying no.
Right, so A star actually gets quite expensive if the answer is you have disconnected parts of the graph.
Ah,
Because it
yeah,
actually searches
right,
the entire graph from both sides and opens every single node on both disconnected sections and says,
right,
okay, I've checked everywhere, nothing's connected.
right. But he checks everywhere. Yes.
But if you make a fake link there and say, this is the link that connects these two graphs,
Ah,
but it's poison,
right. But
now it will do its nice, cheap square root
quick
number
link
of things get
route
opened.
includes poison, and
And
then
then it says, oh, one of the steps in your route is a poison link. The answer is there is no answer.
By the
yeah,
way, on the search engines and LLMs, I am actually finding LLMs more useful than search engines when it's something that I have already done in the past and I know how to do it, like some obscure Git option, and I have just forgotten what the option is. I think the language models right now for me work better for this than Google,
uh,
because Google has gotten so random that
yeah,
if you look for some obscure topics, you're gonna have like tens of hundreds of pages that are completely irrelevant.
yes.
But
It's when I search, it'll be Reddit or Stack Overflow. For that kind of thing, I don't you go to Google. Yeah, because it's gotten so bad. Like, what happened
yeah,
to
it's
Google?
it's pretty much hallucinates relevance, one could say.
Yeah,
You
yeah.
get as much hallucination as you can get on language models, it's just a different kind of hallucination.
All right. I think we're well off the compiler track here, so I'm going to call it. Fun conversations today, and I hope to see people next week.
Have a
All
good
right.
weekend.
Yeah, the LLMs are not yet ready for the query of please turn this code into x86 assembly.
No. All right. Bye bye.
Bye.